Okay, let's dive right into this. Welcome to the Explainer. Today, we're tackling a complete PLC programming tutorial. We're going to cover the core concepts, the working principles, and some really cool real-world industrial use cases. Now, if you've spent any time around high-speed manufacturing or, say, complex assembly lines, you already know the massive scale of coordination that's required. So today, we're literally getting under the hood of the factory brain that makes all this modern automation possible. I mean, think back to the old way of doing things. Before digital logic, factory floors relied on these terrifying, tangled nightmares of hardwired relay panels. It was basically a copper wire spaghetti monster. And if a single connection came loose, well, finding that fault was literally like looking for a needle in a mechanical haystack. But then, the PLC completely changed the game. It took these massive walls of mechanical chaos, completely digitized them, and streamlined all that physical wiring logic right into elegant software. So what exactly is it? At its core, a programmable logic controller, or PLC, is a ruggedized industrial computer. But unlike that delicate laptop sitting on your desk, this thing is engineered to survive harsh, vibrating, dirt-filled factory environments. It acts as the central nervous system of the operation, translating sensory inputs, like a switch flipping, into muscular actions, like firing up a motor or opening a valve. Here is our roadmap for this explainer. 1. Meet the factory brain. 2. How PLCs actually work. 3. Programming logic made simple. 4. Real-world industrial impact. And 5. Your automation solutions partner. Let's jump in. Section 1. Meet the factory brain. Let's look at the introduction and the core benefits. Honestly, the benefits of upgrading to a PLC are just impossible to ignore. First off, you get extreme reliability. Because it uses solid-state electronics, there are literally no mechanical parts wearing out over time. And troubleshooting? It becomes incredibly easy. The software highlights exactly where a sequence stopped. Plus, the programming is wildly flexible, meaning you can just rewrite a few lines of code instead of rewiring an entire room. And the best part? All of this capability is packed into a highly efficient, super compact size. Moving right along to Section 2, how PLCs actually work. We'll cover the components and principles. When we break down the actual components of a PLC, the human body analogy fits so perfectly. The power supply, well, that's the energy keeping the whole system alive. The inputs are the senses. Think push buttons, temperature gauges, optical eyes detecting the real world. Then you have the CPU, which is the actual brain executing the logic. And finally, the outputs. Those are the muscles, the motors, the pumps, and the alarms that are doing all the physical heavy lifting. Now, all these components communicate through what's called the continuous scan cycle. It works in 3 distinct steps. Step 1, it reads the inputs to get a snapshot of the real world. Step 2, it executes the logic, meaning the CPU runs its code against that exact snapshot it just took. And step 3, it writes the outputs to send commands to those physical muscles. And here's the crazy part. This loop repeats thousands of times a second, continuously without ever missing a beat. Okay, on to Section 3, programming logic made simple. Let's look at some examples. So, you might be wondering, how do we actually talk to this factory brain? Well, the absolute genius of early PLC programming is that it wasn't built for computer scientists. It was actually designed intuitively for electricians who were already used to reading physical wiring diagrams. Let's look at a quick example to see how this translates. In basic human logic, we'd say something like, hey, if a button is pressed, turn on the motor, right? Well, in PLC logic, you simply drag and drop a digital symbol for a switch and connect it to a digital motor on your screen. When that input condition is met, virtual power flows through the logic, and boom, the output fires. It seamlessly translates human intention directly into digital execution. Which brings us to Section 4, real-world industrial impact. Let's explore the applications and use cases. When you scale this technology up, the applications are absolutely massive. We're talking about PLCs coordinating robot welding arms on giant automotive lines down to the exact millimeter. They control high-speed bottling plants, incredibly complex packaging systems, and literally miles of warehouse conveyor belts. The hidden digital logic of a PLC touches virtually every single modern manufactured item you interact with today. To really picture this, just take a simple soda bottle assembly line. A sensor detects an empty bottle rolling up. The PLC reads that input and opens a valve for the exact millisecond needed to fill it up. Then, another sensor confirms it's full. Immediately, the PLC triggers the capping machine. Next, a laser inspects the cap's alignment, and if it's even slightly off, the PLC fires a quick blast of air to reject it right off the line. And this entire flawlessly orchestrated dance, it happens in just fractions of a second. It's really amazing. Finally, Section 5, your automation solutions partner, Devi Automation. Look, designing and actually implementing this kind of technology requires some serious expertise, and that is exactly where Devi Automation Solutions steps in. They are essentially your turnkey provider for industrial automation and PLC programming, but honestly, they go way beyond just that. They integrate HMI operator screens, SCADA data collection systems, AI, the industrial Internet of Things, smart agriculture, home automation, and even solar solutions. They aren't just supplying components, they are architecting fully intelligent systems from the ground up. You really don't have to navigate all this complex tech alone. If you found this explainer valuable, definitely make sure to hit subscribe for more tutorials like this. And if you're ready to optimize your own operations, reach out directly to Devia Automation Solutions at gmail.com to get an expert guide on your side. Moving from those terrifying tangled wires to clean digital logic completely changed manufacturing forever. So think about your own operations for a second. If a simple logic controller can revolutionize an entire factory floor, what part of your business is just waiting to be automated? Thanks so much for joining me on this explainer, and we will see you next time.